Testing 1, 2, 3. Testing 1, 2, 3. This is the first photosynthesis lecture. I'm going to try to keep my videos 5 to 10 minutes so that students have the opportunity to digest them. We have the photosynthesis exam that is due on Monday, March 30th. And there's an online photosynthesis lab I encourage you to complete if you have not already. During these live streams, I am looking at my Canvas messaging as well as the Facebook Messenger. I'm broadcasting on multiple platforms, and I will be broadcasting during normally scheduled class times live, so that if you have any questions, that is the best time to interact. I'm going to show you a couple ways that you can interact. If you go to Canvas and you navigate to our class, I've made some announcements on the landing page. I have a COVID-19 class announcement link that brings you to the announcements page, or you can click on announcements, and I encourage you strongly to check my class announcements each and every day. So I had an announcement that I posted that has an introductory video that includes links for this site. I'm going to post now the live link to the Facebook page that I'm using, that you can capture the stream, Mr. Siegel's live classroom stream, and you just click like the page, and then it will send you the updates as well as when I'm about to go live. And you can see I'm going to take this link right now and copy this link, and I'm going to bring that link into a Canvas announcement that's going to include this video. That link is going to pop up here in a second. I'm going to make a new announcement with the sequence of photosynthesis lectures. This announcement will pop up shortly. And I'm typing in that link now. Now, each time I'm live streaming, it'll be a slightly different link, but it's going to be from the same Facebook live streaming page. So as long as you press like on that page, you'll be able to get the link. Could have swore I just said copy that. Copy the link. Okay, it doesn't want to do that. Stand by. Stand by. In the meantime, while you're standing by, let me play you some music. Silly technology.
Look at your hands, oh, hands that shake. shaped the world, oh, for all to see. Stop and think. Oh, as time goes on, why have you left me? Oh, here all alone. I look up to the summer moon. I thank the stars, baby, I feel in tune. Oh no, the wrinkle in skin, it's just a ripple in time. Oh yeah, everything's fine. Everything's fine. Just take me back, salty seaside sunset, down to the island. I just wanna go, stay out of this hole. Yesterday was 100 years ago. Don't ever let go. Tomorrow it's not promised. The present a gift. What is reality? Where do I want to be? You are where you want to be. Oh no, the wrinkle in skin, it's just a ripple in time.
If you're tuning in to Mr. Siegel's live class, I'm here. I'm just playing around with my technology. If you have any comments, type them into the Facebook box.
Look at the ground, put your feet down on the island. Let's roll in the sand. Just take me with you, get away from everything and anyone and anything we might have had to do today. Do today, do today. Get out this place, save me from myself. Take me to that salty seaside sunset in my mind. We gon' get real high. Another wrinkle in skin, it's just a ripple in time. Oh yeah, everything's fine. Everything's fine.
I think this link may or may not work. I'm hoping I get some student feedback. In a few minutes, I'm going to start with my first photosynthesis lecture. And again, I will be recording this.
Go, go, go! Go, go, go! I'm going down to the record store. Guess it's time to spend my last dollar. Never been in this place before. Start to think, why should I bother?
You are in Mr. Siegel's classroom. If you have any comments, post a comment. We will be starting a photosynthesis lecture here momentarily.
Go, go, go! Go, go, go! I went down to Mexico. Had to spend what I could borrow just to let the whole world know. Takes a lot to drown my sorrow. I never have felt so alive. Everything will be okay. Things we do just to get high. Now I've found another way. Go!
welcome to the first photosynthesis lecture. In this lecture, we're going to be talking about the electromagnetic spectrum. There are lecture notes available on the Canvas site. If you click into modules and navigate down to the photosynthesis unit, I have posted my lecture notes, photosynthesis lecture notes. And I strongly encourage you to have completed or soon complete reading the photosynthesis chapter, which we did talk about before spring break. And the first concepts we need to talk about with regards to photosynthesis is electromagnetic energy. Electromagnetic energy. I'm going to be abbreviating electromagnetic energy as EM. Electromagnetic energy. And I strongly encourage you to go over to Google and just type in electromagnetic energy, and you see it pops up, the electromagnetic energy spectrum. And I'm going to click on images, and here's a really good one that popped up right off the bat. The electromagnetic energy spectrum includes radio waves, microwaves, visible light that are visible to our eyes, ultraviolet radiation, X-rays, and gamma rays. The sun emits all frequencies of electromagnetic energy, and man has learned how to manipulate some of the spectrums of electromagnetic energy. What we can see with our eyes is in the visible light spectrum from blue through red, and you see that in the middle, the visible light spectrum. But radio waves, microwaves, ultraviolet radiation, and X-rays are also electromagnetic radiation. Take 10,742. You are in Mr. Siegel's Biology 1 class. This is the first lecture on photosynthesis. And there's a couple ways that you can access these live streams. They will be posted as videos in the Canvas course content throughout the course. If you're on Facebook, you can navigate to Mr. Siegel's live classroom stream. Click like so that you can get notifications when I am live streaming during regular class times. And you can put questions and comments in the live stream box. These videos are also going to be posted inside of the Canvas course content. So when you navigate to this class, our Biology 1 class, I have a link to announcements where I have an introductory video of how the class will proceed here for the next few weeks. And now I'm going to click in the modules. We are in the photosynthesis module. And I have put my lecture notes into that photosynthesis module. And I strongly encourage you to finish reading the chapter on photosynthesis, chapter 6 in the textbook. That test is due online on Monday, March 30th. I want to first start talking about electromagnetic energy, which I will be abbreviating EM for electromagnetic energy. Throughout my lecture series on photosynthesis, I'll be referring to electromagnetic energy frequently as EM. Electromagnetic energy is also known as radiant energy. And radiant energy implies that it's coming from the sun. The sun emits all frequencies of electromagnetic radiation. And there is a spectrum of energy of electromagnetic radiation. And that goes from radio waves, microwaves, infrared, visible light detectable by your eye, ultraviolet radiation, X-rays, and gamma rays. I do want to give you a little explanation on the physics of electromagnetic energy, and this is covered in the textbook as well. Electromagnetic energy travels in waves, and when we look at frequency, we're describing a wavelength where a wave begins and the next wave begins and ends. The next wave, there's one wavelength, there's two wavelengths, there's three wavelengths. The way to think about this is like a circle. We're going to take a circle, and if you take one trip around the circle, you've gone 360 degrees. That is one wavelength. And the reason I say that that's one wavelength, one trip around the circle, is because if I take the circle and I take the top half of it and I flip it around, then I have a complete wave that has a beginning and an end. And this is called one wavelength. And we like to attach a unit of time to that, and that's going to be a second. One wavelength per second is called a hertz, or 1 hertz. If I draw two wavelengths in that same increment of time, that's 2 hertz, 2 wavelengths per second. Now I'm going to go back to the electromagnetic energy spectrum, and you see that it's showing you the wavelength up towards the top. You see long wavelengths, radio waves, infrared waves are getting a little shorter, X-rays are even shorter, gamma rays are even shorter. And if you look right in the middle, what is the sliver of light that is detectable? Light is electromagnetic energy that your eyes are able to detect. And it's at a wavelength that's pretty small. The NM stands for nanometers, or 1/billionth of a meter. So as we go to the top, we see the 1 meter wavelength, the 1,000 meter wavelength, meaning one wavelength is more than a mile long. And as we move to the other side of the electromagnetic spectrum, that 10 to the minus 5 nanometers, that is a tiny, tiny wavelength. with billions and billions of cycles per second. Whereas on the long end of the wavelengths are so long that they don't fit into a second. Now, what our eyes can see right in the middle of the electromagnetic spectrum is going to run between about 790 nanometers, billionths of a meter, and that's going to be in the red area, all the way to a higher electromagnetic frequency of about 390. That's my boss. I better take that call. Yes, sir. I just want to let you know that I